Number 100 Facts About Dinosaurs, a Sleep Story. Hello there, and welcome to Cosmic Sleep Stories. I'm so glad you found your way here tonight. Maybe you've always been fascinated by dinosaurs, those magnificent creatures that ruled Earth for over 160 million years. Or perhaps you're curious about mass extinctions, about how life persists through unimaginable catastrophes. Either way, you're exactly where you need to be. You can rest now. Tonight, you have nothing to do but let go. Let your breathing slow, steady as the footsteps of a giant sauropod crossing ancient plains. Let your body relax, sinking into comfort like fossils settling into sediment over millions of years. Let your mind drift backward through time, past human civilization, past the ice ages, past the rise of mammals, all the way back to when Earth belonged to creatures so strange, so magnificent, that they seem almost impossible. Over the next hour and more, we'll journey together through 100 gentle truths about dinosaurs, from their humble beginnings in the Triassic period to their dramatic extinction at the end of the Cretaceous. We'll meet the giants and the hunters, the flyers and the swimmers, the horned and the armored. We'll explore how they lived, how they evolved, and how they vanished, leaving only bones and stones as evidence of their 160 million year reign. Some facts will captivate you. Others will simply wash over you like ancient tides, leaving only soft impressions as you drift towards sleep. There's no need to remember every name or date. Just let the story unfold. Let yourself be carried back through deep time to when the world was young and strange, when continents drifted and climates changed, when life experimented with forms both beautiful and terrifying. Let the wonder of it all surround you like a warm blanket. And before we begin our journey through the age of dinosaurs, if these quiet, prehistoric explorations help you unwind at the end of your day, consider subscribing to Cosmic Sleep Stories. It helps others find this peaceful corner of deep time, one sleepy soul at a time. Now, close your eyes if you'd like. Breathe slowly, feeling yourself grounded in the present even as your mind travels to the distant past. And let's begin our journey through the Mesozoic era, through 160 million years of dinosaur dominance. Hashtag the world before dinosaurs. To understand dinosaurs, we must first understand the world they inherited. Earth, 252 million years ago, was a very different place. All the continents were joined together into a single massive supercontinent called Pangaea, stretching from pole to pole, surrounded by a single vast ocean called Panthalassa. There were no humans, no mammals larger than a rat, no flowering plants, no grass. It was an alien world, and it was recovering from the worst catastrophe in the history of life. The Permian-Triassic extinction event, sometimes called the Great Dying, had just occurred. This was the most severe mass extinction ever recorded, far worse than the one that would later kill the dinosaurs. Approximately 96% of all marine species and 70% of terrestrial vertebrate species went extinct. The cause is still debated, but massive volcanic eruptions in what is now Siberia, releasing enormous amounts of carbon dioxide and triggering rapid global warming, ocean acidification, and oxygen depletion, probably played a major role. In the aftermath, Earth's ecosystems were devastated, nearly empty. But life, remarkably resilient, began to recover. New groups of organisms emerged to fill the vacant niches. Among them were the archosaurs, the ruling reptiles, a diverse group that would split into two main lineages. One would lead to crocodiles, the other would lead to dinosaurs, and, eventually, birds. The first dinosaurs appeared in the early part of the Triassic period, around 230 to 240 million years ago. They were small, probably no larger than a large dog, bipedal, carnivorous, with hollow bones and three-toed feet. They didn't look particularly impressive compared to some of the other animals around at the time. Early dinosaurs had to compete with other archosaurs, with large crocodile-like predators, with mammal-like reptiles called synapsids that dominated many ecosystems. For tens of millions of years, dinosaurs remained relatively small and uncommon, overshadowed by other groups. But they had certain advantages. Their upright posture, with legs positioned directly beneath their bodies rather than sprawling to the sides, made them efficient walkers and runners. Their hollow bones made them lighter without sacrificing strength. Their respiratory system, similar to modern birds, was remarkably efficient, allowing sustained activity even in low-oxygen environments. These advantages would become crucial. Near the end of the Triassic period, about 201 million years ago, another mass extinction occurred, the Triassic-Jurassic extinction event. Again, the exact cause is debated, but massive volcanic eruptions associated with the breakup of Pangaea likely played a role. This extinction eliminated many of the dinosaurs' competitors, opening up ecological opportunities. And the dinosaurs seized them. In the Jurassic period that followed, dinosaurs diversified rapidly, evolving into an astonishing variety of forms, from tiny feathered predators to the largest land animals that ever lived. For the next 135 million years, from the beginning of the Jurassic through the end of the Cretaceous, dinosaurs would dominate terrestrial ecosystems across the globe, becoming the most successful group of large land animals in Earth's history. As you rest now, imagine that deep stretch of time. 160 million years. Humans and our hominin ancestors have existed for only about 7 million years. Recorded human history spans less than 10,000 years. Dinosaurs ruled for 160 million years, a span so vast, it's almost impossible to truly grasp. Individual species came and went. Continents drifted apart. Climates changed from greenhouse to icehouse and back again. And through it all, dinosaurs persisted, adapted, thrived. Let that vast timescale be comforting somehow. Your worries, your concerns, the things keeping you awake, all of it is fleeting, temporary, a brief moment in the incomprehensibly long story of life on Earth. Dinosaurs rose and fell, empires of scales and teeth and bone, and the world continued. Life continued. And you, lying here now, are part of that same unbroken chain, that same miraculous persistence of life through changing circumstances. Let yourself be part of the story. Let yourself rest in the knowledge that life goes on, that change is constant, that nothing lasts forever, and that's okay. Breathe slowly, feeling the ancient rhythms, the patterns that have sustained life for billions of years, carrying you now towards sleep. Hashtag the giants among giants. When most people think of dinosaurs, they think of size. And indeed, dinosaurs included the largest land animals that ever existed, creatures so massive they challenge our ability to comprehend them. The sauropods, long-necked herbivores, were the true giants of the dinosaur world, and nothing before or since has matched their terrestrial bulk. Argentinosaurus, discovered in Argentina and living during the late Cretaceous period about 95 million years ago, may have been the largest land animal ever. Estimates vary, based on incomplete fossil remains, but this colossal dinosaur probably weighed between 80 and 100 metric tons, perhaps more. That's as much as 15 or 20 elephants, all in a single animal. It stretched perhaps 35 to 40 meters from nose to tail, longer than 3 school buses parked end to end. How could such an animal exist? How could bones and muscles support such incredible mass? The answer lies in several adaptations. Sauropods had hollow bones, filled with air sacs connected to their respiratory system, drastically reducing weight without sacrificing strength. Their long necks allowed them to reach vegetation across a wide area without moving their massive bodies. Their columnar legs, positioned directly beneath their bodies, transferred weight efficiently to the ground like the pillars of a cathedral. And they likely grew continuously throughout their lives, never really stopping, though growth rates slowed as they aged. This is different from mammals, which typically reach adult size and then stop growing. Sauropods just kept getting bigger, and if they avoided predators and disease, they could live for many decades, perhaps even over a century, growing larger and larger the whole time. Other sauropods rivaled Argentinosaurus in size. Patagodoton, also from Argentina, may have been equally large. Dreadnoughtus, whose name means fears nothing, weighed around 65 tons and is one of the most complete giant sauropod skeletons ever found, giving us detailed information about how these animals were built. Brachiosaurus, the classic long-necked dinosaur, was smaller but still enormous, weighing around 50 to 60 tons, with front legs longer than its hind legs, giving it a giraffe-like posture. Imagine encountering such a creature. The ground would shake with each footstep, tremors you could feel through your whole body. Its head would loom high above, perhaps 13 or 14 meters off the ground, as high as a 4-story building. Its tail, thick as a tree trunk, would stretch behind it, occasionally cracking like a whip. And yet, despite its size, it would be a gentle giant, peacefully browsing on vegetation, stripping leaves from trees, swallowing them whole without chewing, letting them ferment in its enormous gut. Sauropods had tiny heads relative to their body size, with simple peg-like teeth suitable only for stripping leaves, not for chewing. All the digestive work happened in their massive guts, probably aided by gastroliths, stomach stones that helped grind up plant material. They must have eaten constantly, consuming hundreds of kilograms of vegetation daily to fuel their enormous metabolisms. Were they warm-blooded or cold-blooded? This is still debated. Probably something in between, what's called mesothermic or gigantothermic. Their sheer size would have helped maintain stable body temperature, as large bodies lose heat slowly. They couldn't cool down or warm up quickly, but they wouldn't need to, their thermal inertia keeping them relatively stable. Living alongside these giants were other large herbivores, but also the predators that hunted them, or at least hunted their young. A full-grown Argentinosaurus had little to fear from predators, simply too massive to bring down. But their eggs and hatchlings were vulnerable. Young sauropods faced years or decades of growth before reaching safe sizes, and many must have fallen to predators during that vulnerable period. As you drift now, imagine lying beneath a prehistoric sky, looking up at a sauropod passing overhead, its shadow briefly blocking the sun, its footsteps reverberating through the ground, a living mountain moving across the landscape. It's so large it barely seems real, more like a landscape feature than an animal, a breathing, living piece of the earth itself. Let that image carry you deeper into relaxation. You are small and safe, lying still while giants walk the earth, or walked the earth, millions of years ago in a world that no longer exists except in fossils and imagination. Let the peaceful browsing of ancient giants be a lullaby, the tremor of their footsteps a gentle rhythm carrying you towards sleep. Hashtag the hunters, predators of the Mesozoic. For every giant herbivore, there was a predator to match it, or at least to try. The theropods, the bipedal carnivorous dinosaurs, included some of the most formidable predators ever to walk on land. And the most famous of them all, the king of the dinosaurs, is Tyrannosaurus rex. T. Rex lived at the very end of the Cretaceous period, about 68 to 66 million years ago, in what is now Western North America. It was enormous, up to 12.3 meters long and weighing perhaps 8 to 14 tons, as heavy as an elephant. It stood about 4 meters tall at the hips, though its head, held forward on its powerful neck, could reach much higher. Its skull was massive, over 1.5 meters long, built to withstand enormous stress. Its jaws were filled with teeth, some over 30 centimeters long, including the root, the largest teeth of any land carnivore. These weren't blade-like slicing teeth like those of most theropods, but thick, conical, bone-crushing teeth capable of biting through solid bone, generating bite forces estimated at over 12,000 pounds, stronger than any other land animal measured. T. Rex hunted large prey, probably including Triceratops and Edmontosaurus, both abundant in its ecosystem. Whether it was primarily an active hunter or a scavenger is debated. Most likely it was both, like modern lions, taking fresh kills when possible, but not above eating carrion when the opportunity arose. Its sense of smell was excellent, with large olfactory bulbs suggesting it could detect scents from great distances. Its arms were tiny, almost comically small relative to its body, with just 2 fingers. For a long time, paleontologists thought these arms were vestigial, useless, but recent research suggests they were actually quite strong, perhaps used to grip struggling prey or to help the animal stand up from a resting position. They were not useless, just specialized for tasks that didn't require long reach. But T. Rex, famous as it is, was not the largest theropod. That distinction goes to Spinosaurus, a bizarre semi-aquatic predator from Cretaceous North Africa. Spinosaurus was longer than T. Rex, perhaps up to 15 meters, though probably not as heavy. It had a crocodile-like skull with conical teeth suited for catching fish, and most remarkably, a huge sail on its back formed by elongated vertebral spines covered in skin. What was the sail for? Thermoregulation, perhaps, helping warm up or cool down by turning its broad profile toward or away from the sun. Display, possibly, making it look larger and more impressive to rivals or mates. Fat storage, some suggest, though this seems less likely given the structure. We don't know for certain, and the mystery adds to Spinosaurus's already alien appearance. Recent discoveries suggest Spinosaurus spent much of its time in water, hunting fish and possibly other aquatic prey. Its bones were dense, unlike most theropods, which would have helped it dive and swim. Its hind feet were possibly webbed or at least paddle-like. It was a strange mosaic, part crocodile, part dinosaur, filling a niche unique among theropods. Other large predators stalked different times and places. Giganotosaurus from Argentina may have hunted the giant sauropods in packs, though evidence for pack hunting in large theropods is limited and debated. Carcharodontosaurus from North Africa was similarly massive. Allosaurus, from the Jurassic period, was smaller than T. Rex, but still formidable, the top predator of its time and place. And there were smaller predators too, fast and agile, some no larger than chickens. Velociraptor, made famous by Jurassic Park, was actually quite small, about the size of a large turkey, covered in feathers, with a large sickle claw on each hind foot used for pinning down prey. The movie drastically exaggerated its size, but the real animal was still an efficient predator, intelligent for a dinosaur, possibly hunting in coordinated groups. Deinonychus, a larger relative of Velociraptor from North America, was the model for the Jurassic Park raptors, though it too was smaller than depicted. These dromaeosaurs, the raptor family, represented a different hunting strategy than the large tyrannosaurs. Speed and agility rather than brute force, precision strikes with their sickle claws rather than crushing bites. As you rest, imagine the Cretaceous night, stars overhead in unfamiliar configurations, continents in wrong positions, the climate warmer, the air different. And in the darkness, predators moving, some hunting alone, others perhaps in coordinated groups, using senses we can only infer from fossilized skulls, employing strategies we reconstruct from trackways and bone beds. They're all gone now, every one of them, extinct for 66 million years. The last T. Rex died millions of years before the first human ancestor walked upright. We're separated from them by an abyss of time so deep that we can barely comprehend it. And yet here you are, thinking about them, giving them a kind of immortality in memory and imagination, bringing them back to life, if only in your mind, as you drift towards sleep. Hashtag feathers, colors, and sounds. For most of the history of dinosaur paleontology, we imagine dinosaurs as scaly reptilian creatures, slow and sluggish, colored in drab greens and browns. But discoveries over the past few decades have revolutionized our understanding, revealing that many dinosaurs were covered in feathers, that some were brilliantly colored, and that they likely made diverse sounds that filled Mesozoic forests with calls and songs. Feathers evolved in dinosaurs long before flight. The earliest feathers were simple filaments, more like hair than modern bird feathers, probably used for insulation. Remember, many dinosaurs were active, energetic animals with high metabolisms, and they needed to retain body heat. As feathers evolved, they became more complex, developing branches and structures suitable for display, for species recognition, for attracting mates. Flight feathers, the specialized asymmetric feathers needed for powered flight, evolved later, in small theropods that would eventually become birds. But many non-flying dinosaurs had elaborate feathered coverings, plumes and crests and tails that made them look more like exotic birds than the reptilian monsters of old movies. Velociraptor had feathers. We know this from quill knobs on its arm bones, attachment points for flight feathers. It couldn't fly, but it had feathered forelimbs, possibly used for display or for covering nests of eggs. Microraptor, a small dinosaur from China, had 4 wings, feathered arms and legs, and could probably glide between trees like a flying squirrel. Utaranus, a relative of T. Rex from China, was covered in long, shaggy feathers despite weighing over a ton, the largest known feathered dinosaur. Did T. Rex itself have feathers? This is debated. It's possible young T. Rex had feathered coverings that they lost as they grew larger, as large size makes retaining heat easy and losing excess heat difficult. Adults may have had scaly skin, but juveniles might have been fluffy. Without direct fossil evidence of T-Rex skin from all body parts and life stages, we can't be certain. Even more remarkably, we can now determine the colors of some dinosaurs. Fossilized melanosomes, the pigment-containing organelles and feathers, preserve different shapes depending on what color they produced. Black feathers have sausage-shaped melanosomes. Brown feathers have spherical ones. By comparing fossilized melanosomes to those in modern birds, paleontologists can reconstruct color patterns. Anchiornis, a small feathered dinosaur from China, was black and white with a red crest. Microraptor was black with an iridescent sheen, like a crow. Sinosauropteryx had a striped tail, reddish-brown, and white bands, possibly used for communication or display. These weren't the drab reptiles of outdated reconstructions, but colorful, visually striking animals. What sounds did dinosaurs make? We can't know for certain, as soft tissue doesn't fossilize, but we can make educated guesses based on anatomy and on modern relatives, birds and crocodiles. Dinosaurs likely couldn't roar like in movies. Roaring requires specialized vocal structures that mammals have but birds and crocodiles lack. Instead, dinosaurs probably made sounds more like those of modern birds: calls, cries, hoots, booms. Some dinosaurs had elaborate crests and hollow structures in their skulls that could have resonated, amplifying sounds. Parasaurolophus, a duck-billed dinosaur, had a long hollow crest that acted like a trombone, producing deep resonant calls that could have carried for kilometers. Different species had differently shaped crests, probably producing different sounds, allowing species recognition. Lambeosaurus, another crested hadrosaur, could probably produce complex vocalizations, varying pitch by contracting muscles around its crest. Imagine a Cretaceous forest filled with these sounds: booming calls from Parasaurolophus, higher-pitched cries from smaller species, the hiss and growl of predators, the sounds of feet tramping through undergrowth, all creating a sonic landscape utterly unlike anything in the modern world. And they probably communicated visually too, using their colors and crests and frills and horns in displays. Triceratops's massive frill, previously thought to be defensive armor, was probably more for display, for species recognition and mate attraction, like a peacock's tail or a deer's antlers. Stegosaurus's plates, Ankylosaurus's armor, Carnotaurus's horns, all likely served display functions alongside any defensive utility. As you rest now, imagine that world of color and sound, so different from the monochrome museum skeletons that shaped early dinosaur imagery. Imagine feathered predators with iridescent plumage stalking through forests, their calls echoing. Imagine herds of hadrosaurs with elaborate crests, each species producing distinctive sounds, creating a cacophony that announced their presence kilometers away. Imagine the visual displays, the bright colors, the posturing and showing off, all the complexity of social behavior we see in modern animals, present then too in different forms. And as these images drift through your mind, becoming less clear, more dreamlike, let them carry you deeper toward sleep, toward the land where imagination and memory blur together, where dinosaurs walk again, not in reality but in the theater of dreams. ## eggs, nests, and parenting. Dinosaurs laid eggs, as do all modern birds and most reptiles. This simple fact reveals much about their biology and behavior. Fossilized dinosaur eggs have been found on every continent, some perfectly preserved, some containing embryos that show how baby dinosaurs developed. Dinosaur eggs varied tremendously in size, from chicken egg size to over 60 centimeters in length. But even the largest dinosaurs had relatively small eggs compared to their body size, constrained by the need for eggshells to be thick enough to protect the embryo, but thin enough for oxygen to diffuse through and for the baby to break out when hatching. The largest dinosaur eggs were probably laid by sauropods, though we haven't definitively matched many sauropod eggs to specific species. The eggs were buried in nests, sometimes elaborate structures, sometimes just holes in the ground. Some dinosaurs returned to the same nesting sites year after year, creating vast nesting colonies where hundreds or thousands of individuals would nest together. Maiasaura, whose name means good mother lizard, was discovered with extensive nesting sites in Montana showing multiple generations of use. The nests contained eggs, newly hatched babies with worn-down teeth suggesting they'd been fed in the nest, and juveniles at various stages of growth, implying extended parental care. This was revolutionary when discovered in the 1970s, challenging the prevailing view of dinosaurs as neglectful reptilian parents. We now know that many dinosaurs, especially those most closely related to birds, showed sophisticated parenting behaviors. Oviraptor, whose name ironically means egg thief, because the first specimen was found near eggs thought to belong to another species, was actually brooding its own eggs, sitting on them to keep them warm, exactly as modern birds do. Several specimens have been found in brooding positions, covering their nests with their feathered arms, preserved in that protective posture for 75 million years. Trudon, a small intelligent theropod, also brooded its eggs. Its nests show careful arrangement of eggs and spiral patterns, and its leg bones show annual growth lines that suggest nesting season was synchronized with food availability, just as in modern birds. This level of behavioral complexity, previously attributed only to birds and mammals, was present in dinosaurs millions of years before either group became dominant. Did all dinosaurs care for their young? Probably not. Large sauropods likely laid eggs and left them, as sea turtles do today. The babies would hatch and fend for themselves from day one, already capable of walking and feeding, though vulnerable to predators. Their strategy was quantity: lay lots of eggs, and enough offspring would survive to maturity even with high infant mortality. But smaller dinosaurs, especially theropods, likely invested more in each offspring, providing care and protection, teaching hunting skills in some cases. Dinosaurs occupied a spectrum of parenting strategies, from none at all to intensive care, adapted to their size, ecology, and life history. Some dinosaur eggs contain beautifully preserved embryos, allowing us to study development. The embryos show that baby dinosaurs didn't look like miniature adults. Their proportions were different, heads larger relative to body size, limbs shorter, features we associate with cuteness in mammals, suggesting similar evolutionary pressures shaped by parental care. And some eggs contain fossilized soft tissue, pigments that reveal egg colors. Some dinosaur eggs were blue-green, like robin's eggs. This color, produced by biliverdin pigments, is rare in modern reptiles but common in birds, suggesting the eggs were visible in nests, not buried and hidden like most reptile eggs. Visible eggs require parental guarding, another indication of parental care. As you rest now, imagine a Cretaceous nesting ground, dozens of dinosaur nests scattered across a floodplain. Adults stand guard, watching for predators, occasionally calling out warnings or territorial challenges. In the nests, eggs are incubating, some already cracking, tiny snouts breaking through tough shells, emerging into a dangerous world where only parental protection offers hope of survival. Life continues, generation after generation, the ancient imperative to reproduce, to pass on genes, to care for young. Dinosaurs followed this imperative for 160 million years, succeeding spectacularly, filling the earth with diverse lineages. And now, as you drift toward sleep, you follow your own imperative to rest, to restore, to prepare for tomorrow, continuing the unbroken chain of life that connects you to those ancient nesting grounds, to the parents and offspring of the Mesozoic, to all life that has ever existed. Hashtag the extinction, day of impact. For 160 million years, dinosaurs dominated terrestrial ecosystems. They survived climate changes, sea level fluctuations, the breakup of Pangea, countless smaller extinction events. They adapted, diversified, thrived through changing circumstances. And then, 66 million years ago, it ended. The Cretaceous-Paleogene extinction event, often called the KPG extinction or KT extinction, wiped out all non-avian dinosaurs, along with about 75% of all species on Earth. It was sudden, geologically speaking, occurring over a few thousand years or perhaps even faster. The cause is now well established. An asteroid impact combined with massive volcanic eruptions created a perfect storm of environmental catastrophe. The asteroid, roughly 10 to 15 kilometers in diameter, struck what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater, one of the largest impact structures on Earth. The impact released energy equivalent to billions of nuclear weapons, vaporizing rock, creating a blast wave that circled the globe multiple times, triggering earthquakes, tsunamis, and wildfires across entire continents. The immediate devastation was apocalyptic. Everything within thousands of kilometers was incinerated instantly. Molten rock and superheated gas shot into the stratosphere, spreading globally. As this material fell back to Earth, it heated the atmosphere, creating an infrared pulse that lasted for hours, hot enough to ignite vegetation worldwide, turning forests into infernos, killing any animal unable to find shelter underground or underwater. Then came darkness. Dust and soot from the impact and global wildfires filled the atmosphere, blocking sunlight for months, possibly years. Temperatures plummeted. Photosynthesis stopped. Plants died. Herbivores starved. Carnivores, deprived of prey, starved in turn. The food chains collapsed from the bottom up. This was the impact winter, a prolonged period of darkness and cold that devastated terrestrial ecosystems. The darkness was profound, reducing sunlight to less than 1% of normal levels. Without photosynthesis, without new plant growth, the base of the food chain vanished. Large animals, with their high metabolic demands, were especially vulnerable. Dinosaurs, except for small flying forms that would become modern birds, didn't survive. The giant sauropods died. The tyrannosaurs died. The ceratopsians and hadrosaurs died. Across the globe, lineages that had existed for tens of millions of years vanished within a geological instant. But the asteroid wasn't the only stress. At the same time, massive volcanic eruptions were occurring in what is now India, the Deccan Traps, releasing enormous amounts of carbon dioxide and sulfur dioxide. These eruptions had been ongoing for hundreds of thousands of years, gradually warming the climate, acidifying oceans, stressing ecosystems. The asteroid impact arrived when ecosystems were already weakened, delivering a coup de grace to life forms already struggling. Not everything died. Mammals, most of them small, many of them burrowing or semi-aquatic, survived. So did birds, descendants of small feathered theropods. Crocodiles and turtles, able to survive long periods without food, made it through. Many fish survived. Frogs and salamanders persisted. The survivors tended to be small, able to shelter underground or underwater, capable of surviving on detritus and carrion, or having life cycles that allowed them to wait out the catastrophe as eggs or dormant forms. The extinction was selective, but not in ways that suggest justice or fairness. It wasn't the strongest or smartest that survived, but often the luckiest, those whose particular adaptations happened to be useful in the specific conditions of the catastrophe. Dinosaurs had ruled for 160 million years, but size and success before the impact didn't guarantee survival. In the aftermath, the world was empty, ready for new groups to diversify. Mammals, previously small and nocturnal, began to expand into niches left vacant by dinosaurs. Within 10 million years, the age of mammals had begun, leading eventually to primates, to humans, to you lying here now, separated from that extinction event by 66 million years and countless generations. As you rest, think about that asteroid, that random rock from space, and how it changed everything. If it had missed, if it had arrived a few million years earlier or later, if it had struck the ocean instead of land, history would be different. Dinosaurs might still rule. Mammals might still be small and marginal. Humans might never have evolved at all. But it did strike. And everything changed. And here you are, a mammal, a species that couldn't have existed if dinosaurs hadn't died, thinking about those ancient giants, giving them memory, honoring their long reign and sudden ending. Life continues, adapting, filling niches, flowing into whatever form circumstances allow. And you're part of that flow, resting now, restoring for tomorrow, continuing the ancient pattern. Hashtag after the dinosaurs, the age of mammals. In the immediate aftermath of the extinction, the world was bleak. The impact winter gradually faded, sunlight returned, but the planet was scarred. Many ecosystems had collapsed entirely. The recovery would take millions of years, but life, resilient and adaptable, began the slow process of rebuilding. Small mammals that survived the extinction began to diversify rapidly, filling ecological niches left vacant by dinosaurs. Within a few 100,000 years, mammals had evolved larger forms. Within 10 million years, some were as large as modern horses or bears. The age of dinosaurs was over, and the age of mammals had begun. But dinosaurs weren't entirely gone. Birds, which are technically a lineage of theropod dinosaurs, survived and thrived. In fact, there are more species of birds alive today, over 10,000, than there were species of non-avian dinosaurs at any point in the Mesozoic. Birds are the most successful dinosaur lineage, adapting to nearly every environment on Earth, from Antarctic ice to tropical rainforests, from open oceans to high mountains. Every bird you've ever seen, every pigeon, sparrow, eagle, penguin, hummingbird, is a dinosaur, descended directly from small feathered theropods that survived the KPG extinction. When you hear birds singing in the morning, you're hearing dinosaur calls. When you eat chicken or turkey, you're eating dinosaur meat. The dinosaurs didn't go extinct. They evolved, adapted, and they're still here, walking and flying among us. This realization has fundamentally changed how we view dinosaurs. They're not ancient failed experiments, obsolete creatures replaced by superior mammals. They're a continuing success story, a lineage that has persisted for over 230 million years, from the Triassic to the present, adapting to mass extinctions, climate changes, continental reconfigurations, and thriving through it all. Mammals did radiate and diversify spectacularly after the extinction. Primates emerged. Some mammals returned to the ocean, becoming whales and dolphins. Others took to the air as bats. Still others grew enormous, like the giant ground sloths and mammoths. Mammals filled nearly every niche that dinosaurs once occupied, plus some dinosaurs never tried. But dinosaurs, in their avian form, remained important parts of ecosystems, seed dispersers, pollinators, predators, prey. The story of dinosaurs isn't a tragedy of extinction, but a saga of adaptation and persistence through unimaginable changes. Humans evolved much later, only a few million years ago, infinitesimal compared to dinosaur history. We've been around for perhaps 300,000 years as a species, barely a moment in geological time. And yet in that brief span, we've spread across the globe, transformed ecosystems, and driven many species to extinction. We've become a geological force, our impacts visible in rock layers, our era possibly marking a new epoch, the Anthropocene. Will we last as long as dinosaurs did? 160 million years seems impossible to imagine. Will we survive our own asteroid, the climate change and habitat destruction, and other environmental catastrophes of our own making? Or will we adapt, as life always has, finding ways to persist through changing circumstances? These questions remain open, unanswered. But as you rest now, as you drift toward sleep, let them go. Let the deep history of Earth, the rise and fall of dinosaurs, the persistence of life through catastrophes beyond imagination, all of it be a context that makes your personal worries seem smaller, more manageable, less overwhelming. Life continues. It always has. Through impacts and eruptions, through ice ages and warming periods, through extinctions and radiations, life finds ways to persist, to adapt, to diversify. And you're part of that continuity, that unbroken chain stretching back billions of years to the first cells in ancient oceans. Rest in that knowledge. Let it support you like the ground beneath you, solid and reliable. And let yourself drift into sleep, into the daily dissolution of consciousness that is itself a small death and rebirth, a nightly reminder that endings and beginnings are part of the same cycle. #the discovery, finding deep time. Humans didn't always know about dinosaurs. For most of history, dinosaur fossils, when found, were interpreted as the bones of giants, dragons, or monsters from mythology. The scientific study of dinosaurs began only in the 19th century, making paleontology a relatively young science. The first dinosaur fossils formally described scientifically were Megalosaurus in 1824, Iguanodon in 1825, and Hylaeosaurus in 1833, all from England. Richard Owen coined the term Dinosauria in 1842, meaning terrible lizards, recognizing that these fossils represented a distinct group of extinct reptiles. This was revolutionary, challenging prevailing views that all species had existed unchanged since creation, providing evidence for extinction and for life forms that no longer existed. The first dinosaur discoveries captured public imagination immediately. Full skeletons were mounted in museums, reconstructed, sometimes incorrectly, becoming attractions drawing crowds. Dinosaurs entered popular culture, appearing in books, art, and later films, becoming symbols of the deep past, of evolution, of extinction. The late 19th century saw the Bone Wars, a fierce competition between American paleontologists Edward Cope and Othniel Marsh to discover and name new dinosaur species. Their rivalry, often bitter and unethical, nevertheless resulted in the discovery of many important dinosaurs, including Allosaurus, Stegosaurus, Triceratops, and Diplodocus. Dozens of new species were described, filling museums with spectacular specimens. The 20th century brought new techniques. Instead of just collecting bones, paleontologists began studying geology, ecology, and behavior. Trackways revealed how dinosaurs moved. Nesting sites showed parenting behavior. Microscopic examination of bones revealed growth rates and metabolism. Discoveries of feathered dinosaurs in China in the 1990s and 2000s revolutionized understanding of the dinosaur-bird connection. And new technologies continue to reveal secrets. CT scanning allows examination of internal structures without damaging fossils. Synchrotron imaging reveals soft tissue details. Biomechanical modeling tests hypotheses about movement and behavior. Chemical analysis identifies pigments and proteins. Each new technique opens new windows into the past. Amateur fossil hunters continue to make important discoveries. Many significant dinosaur fossils have been found not by professional paleontologists, but by farmers, hikers, children playing in badlands, anyone with curiosity and sharp eyes. Paleontology remains one of the few sciences where amateurs can make genuine contributions, where important discoveries await anyone willing to look carefully. Every fossil tells a story. Each bone represents an individual life, an animal that was born, grew, lived, and died, leaving behind this small trace in rock. When you look at a dinosaur skeleton in a museum, you're looking at a specific individual, not a generic representative. That Tyrannosaurus Rex was a unique being, with its own experiences, its own personality perhaps, its own place in its ecosystem. And every fossil discovery changes our understanding slightly, adding details, correcting errors, filling gaps. We'll never know everything about dinosaurs. Too much is lost, fossilization being a rare and imperfect process. But we know far more than we did even a few decades ago, and every year brings new discoveries, new insights, new species described from rocks that have held their secrets for millions of years. As you drift toward sleep, think about those paleontologists, past and present, carefully excavating fossils from rock, piecing together ancient lives from fragmentary remains. Think about the patience required, the years spent searching, the excitement of discovery, the painstaking work of preparation and analysis. They're time travelers of a sort, reaching back millions of years, bringing dinosaurs back to life through science and imagination. And you, listening to this story, learning about dinosaurs, you're part of that process too. You're connecting with deep time, with the vast history of Earth, with creatures so far removed from your experience that they might as well be from another planet. And yet they lived here, on this same Earth, under the same sun, breathing air and eating and reproducing and dying, following the same basic imperatives that motivate all life. Let that connection be comforting. You're not alone, not isolated. You're part of life's long story, connected backward to dinosaurs and forward to whatever comes next, all of it flowing together, all of it part of the same grand narrative of existence. Hashtag the deep sleep. And now, as we near the end of our journey through dinosaur history, let yourself sink deeper into rest. You've traveled through 160 million years tonight, from the first small dinosaurs of the Triassic through the giants of the Jurassic, the diverse ecosystems of the Cretaceous, to the sudden extinction and the aftermath that shaped the modern world. You've met the giants and the hunters, the horned and the armored, the feathered and the colorful. You've learned how they lived, how they reproduced, how they behaved, how they sounded. You've witnessed their extinction and their continuation in birds. You've connected with deep time, with the vast stretches of Earth history that dwarf all human concerns. And through it all, you've been resting, relaxing, letting your body and mind prepare for sleep. Your breathing has slowed. Your muscles have relaxed. Your thoughts have become less focused, more dreamlike, drifting like fossilized leaves in ancient stone. The dinosaurs are gone, most of them, extinct for 66 million years. The world they knew is gone too, transformed beyond recognition. The continents have moved. The climate has changed. The plants and animals are different. Only rocks and fossils remain, silent witnesses to a vanished age. But in a sense, dinosaurs live on. In birds, obviously, but also in imagination, in the wonder they inspire, in the questions they raise about life and extinction and deep time. They remind us that nothing lasts forever, that dominance is temporary, that even the mightiest lineages eventually end. But they also remind us that life persists, that even mass extinctions don't end the story, that evolution continues, finding new forms, filling new niches. As you rest now, let the dinosaurs rest too. They've been dead for millions of years, their bones turned to stone, their soft tissues long since decayed. What remains of them is permanent in a way, preserved in rock for as long as the rock itself endures. They've found a different kind of permanence, not through continuation but through preservation, frozen in time, eternal in their stony graves. And you're drifting toward your own temporary death, the nightly dissolution of consciousness that is sleep. For the next few hours, you'll be like a fossil, still and silent, time passing without your awareness, the world continuing without your participation. And then, in the morning, you'll wake, consciousness reconstituting like a hatching dinosaur emerging from its shell, ready for another day. But that's tomorrow. Right now, there's only this, the soft darkness, the quiet breathing, the gentle descent into sleep. The dinosaurs have had their turn. They rose and fell, dominated and disappeared, leaving only traces. And you're having your turn now, your brief moment in the sun, your few decades of consciousness and experience. Make it count. But not tonight. Tonight, rest. Let the weight of deep time settle over you like sediment, layer upon layer, burying consciousness, preserving you in the still darkness of sleep. Let 160 million years of dinosaur history be a lullaby, the slow turning of ages carrying you down into dreams. Good night. Rest well. And let the ancient rhythms of Earth, the cycles of day and night, life and extinction, waking and sleeping, all of it carry you safely through the darkness toward the dawn. Sleep now, among the ghosts of dinosaurs, in the quiet night of the present, connected to the deep past and the distant future, resting in the eternal now that is the only time that ever truly exists. Profound silence, the stillness of fossils, the peace of deep time, the beginning of sleep.